Today we are learning about lesson 7-5, and that is factoring linear expressions. Our essential question for the lesson is, how are distributing and factoring related? Let's find out. What are factors? Factors are a thing of the past from elementary school, and they are the multiplying building blocks of numbers. And if you remember, a factor times a factor equals a product. Simply said, 2 times 3 are factors of 6. Now we go down into the next part, a GCF. Now that sounds familiar to you, I'm sure, and that stands for the greatest common factor. And if we were to translate that, we could say the largest familiar, oops, I'm having trouble spelling familiar here. Let me try it again. Familiar ingredient. Now you probably never heard of that because I just made it up. And that's just translating what the greatest common factor is. It's also, you could say, well, that means just the largest familiar ingredient. And so when you bake something or make something in the kitchen, you have ingredients. Those are all the factors that go into making the product, the end product. So let's take a look at two methods to find the GCF. Method 1. This is known as factor trees, and this should be very familiar with you. And we're also going to be listing the prime factors to help us find the GCF. Now this is going to be quite the tree here, so make sure you write kind of small and make sure you have enough room. So we're going to extend this over to here and to right here, and 48 times Rx is 48, and then Rx. And then for 48, that's going to be 2 times 24. And then 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. Rx is R times X. And the reason why we do this is we're looking for the prime factors. And that's what factor trees lead us to. So if we circle all of our prime factors up here, we have a 2, 2, 2, and 3, plus an R and an X. So we know what the prime factorization of 48Rx is. But let's go over to 20R and make a tree. This is 20 times R. And 20 is 2 times 10. 10 is 2 times 5. And 5 is a prime, so we're done there. So the prime factorization of 20R is 2, 2, 5, and R. Now if we list each of these out as 2 times 2 times 2 times 2 times 3 times R times X, that's for our 48Rx. And we also list out our 20Rs in prime factorization, 2 times 2 times 5 times R. Well, we're going to be looking for what they have in common or what's familiar to each of them. And you can see the familiarity starts right here. They both have a 2. They actually both have another 2 that they share. And they both have an R that they share. And once you find that familiarity between the two in their prime factors or their common factors, all you have to do is take those and you write that these pair of 2's as a 2, these pairs as a 2, and these pairs of R's as an R. And you multiply those together and you get 4R. And 4R is the GCF. And that's how you find it. Do you remember factor trees? Probably. All right. There's another method here. So let's go ahead and take a look at the other method. Method 2 is the upside down cake, and all you have to do here is draw an upside down division bar. Now, the reason why it's upside down is just an organizational piece. It's not a math thing, but it is division. So you can look at 48 and 20 and think, what kind of factors do they both have in common? And you might say, oh, let's see, they have a 2 in common. So then you divide. 48rx divided by 2 gives us 24rx. And then on this side, 20r divided by 2 gives us 10r's. Or you could say that 2 times, sorry, not there, let's not do that. 2 times this 2 times 24rx is 48rx, or 2 times 10r is 20r. That would be the distributive property going back up. Okay, so now when we're down to 24rx and 10r, we go ahead and draw another upside down cake. And we're making layers of a cake here. And what does 24 and 10 both have in common? Well, they're both even numbers, so we know we can take out a 2. So what's 24rx divided by 2? It's 12rx. And what's 10r divided by 2? It's 5r. And then there again, we make another layer of the cake. And what does 12rx and 5r have in common as factors? They have r. So what's 12rx divided by r? It is 12x. And what's 5r divided by r? It is 5. Now you got to look at this last part. Does 12x and 5 have any common factors? And the answer is no. And so where do we find the GCF? Well, we find it right here. We multiply all these together and we get 4r. And that is the GCF. Now you can see the difference. It's faster with a cake model than the factor tree. So for the rest of the work today, we will be using the upside down cake. It's also been referred to as the upside down wedding cake, because wedding cakes usually have many, many layers going up. All right, let's go down here and let's use what we've learned, and that is the upside down cake method. It's a method to find what? Common factors of the following. So these are the ones that we're going to try together, and then you're going to have your turn right below. So let's go ahead and start right here on number 1. So first, draw your upside down division bar. And then you got to think, what are some common factors of both 24 and 40? Now I'm going to show you this in 2 different ways. So right next door, I'll write 24 and 40 with another cake right here. Now you could go the slow and tedious way of finding the smallest factors that go in, like 2. Well, 2 goes into 24 12 times, and 2 goes into 40 20 times. And then you make another layer, and 2 goes into 12 6 times, and 2 goes into 20 10 times. And then you make another layer, and 2 goes into 6 3 times, and 2 goes into 10 5 times. And then when you're down here at the 3 and 5, there are no more factors. So if you gather all of these together and multiply them, you get 2 times 2 times 2 is 8. So your GCF is 8. Now come over here with the red one. You don't have to take the smallest factors. You can go for something much larger. Let's say you look at 24 and 40 and you go, you know what? I know that 8 goes in there. And so all you do is write 8 here. 24 divided by 8 is 3, and 40 divided by 8 is 5. And you see how much close or faster you get to the GCF? So the larger that you use, larger factors that you use that are in common, the faster you'll find the GCF. All right, let's take a look at number 2. So we're going to draw an upside down cake. And I know that 2 goes into 12 and 16, but I also know that 4 goes into both. 4 is larger than 2, so it's going to make the path of the cake layers faster. So I'm going to put a 4 right here, and 12x divided by 4 is going to give me 3x's, or 4 times 3, x is 12x. And then down on this next side, negative 16 divided by 4 is negative 4. And there's no factors that go into 3x or negative 4, so my GCF is 4. Number 3. Number 3 is here because both numbers have negatives, and we need to deal with those types a little bit differently. So we'll make our division bar here, and we'll look at 30 and 75. And we'll look, hey, okay, the 5 goes into both, so we're going to take out a 5. So negative 30 divided by 5 is definitely negative 6RT. Try to make this and sign. I'm horrible at this. I just don't like how I make them. And then negative 75 divided by 5 is definitely negative 15 R's. Okay, then you look at negative 6 and you look at 15. You're like, hey, 3 goes into both of those. So you make another layer. And 3 goes into negative 6, negative 2 times. And leave the RT with it. Try to make that and sign again. That's better. And the negative 3 divided by, or sorry, negative 15 divided by 3 is negative 5 R's. And now the numbers are good, but the variables aren't. So we are going to go ahead and take out a variable, which is R. So negative 2RT divided by R is negative 2T. Try to make that and sign again. And negative 5R divided by R is negative 5. Now you think you'd be done, but because both numbers are negative, we can actually take out a negative 1. Okay, we're taking out the negative. And a negative divided by a negative, as you know, is a positive. So negative 2t divided by negative 1 is positive 2t. And negative 5 divided by negative 1 is positive 5. So what's our GCF here? Well, we multiply all of these together. And 5 times 3 is 15, and that 15 times the negative 1 is negative 15, and negative 15 times the r is negative 15r. And that is our GCF, also known as, in our class, the largest familiar ingredient. All right, it's time for you to find the largest familiar ingredient, or the GCF, as commonly known as. All right, so go ahead and pause the video and try number 4 out, and then come back and see if you got it right. Pause now. All right, there you have number 4. Did you get 35A? If you didn't, take a look at my work and my layers and make sure you are doing it correctly. If not, you may want to rewind the video and take a look at the examples up above. Now it's time to do number 5, but before you get started, notice that both numbers have a negative. Pause now. Okay, welcome back. Now you can see that the GCF is negative 2xy, and you may not have gotten negative 2xy just like I did, but if you did, you're doing it right. On this one, I knew that they both have negatives, so I can take out a negative in the very beginning, and I knew that 2 can go into both at the same time. So I'm kind of doing double duty right here. I'm taking out the negative and the 2, and then I do double duty down here too. I take out x and y at the same time. Kind of shortens up my cake, and I get to the GCF faster. All right, now it's time for number 6. Pause the video and try it out. All right, you're back, and the GCF here is 3G. Now I chose to take out a big chunk at the very beginning because I knew 3 went into both. I knew that G went into both. So I decided to take out both factors at the same time. Now sometimes that makes your brain kind of intense, and you don't have to do it like that. You can do many layers and still get to 3G. Now it's a positive 3G because they don't both have a negative sign to take out. All right, let's go down and flip our page to the back side. This one says factoring expressions. And right here is a little quote type thing. It says factoring an expression. Well, what does that mean? It means reverse distributive property. And so let's take a look at this bullet point. Separating an expression back into a product is called factoring. And you can see we have these two flags here, and they have arrows between them. This side over here, you know from a previous lesson, this is called simplest form. And so if this is simplest form, because there's no like terms and there's no parentheses. Now, when we go from this arrow, from this left flag to the right flag here, this is putting it back into factored form. Well, how would you take it from factored form and go back to simplest form? You would use the distributive property. So from going from the right to the left is the distributive property. And going from left to right is factoring, also known as reverse distributive property. Here's the steps to factor. There are 4 of them. Number 1, find a common factor. Now, it doesn't have to be the greatest, but you could. As long as they're common, you'll be fine because we're going to be using the upside down cake. Number 2, divide each term by the common factor. That's just what we were doing on the front side of the notes. We'll also be referring to as factor out and leave the remaining factors in parentheses. Number 3, when possible, factor out a negative. And we learned how to do that on the front. And number 4, check your work by distributing. All right, let's try these together. So we're going to use the upside down cake because it's super simple. And we're going to factor out a 3 here. So 3x divided by 3 is just x left over, and 9 divided by 3 is 3. And is there anything that we can factor out of x plus 3? There's not. So what we do here, and in the directions, you just put parentheses down around that, and then you move the GCF, which is 3, right in front. And that is your factored form. 3 times x plus 3. And we can check it, like the directions said, by using the distributive property. 3 times x is 3x, and 3 times 3 is 9, and bring down the plus sign. And you can see this is in simplified form. But we were factoring. So this would be your official answer in a Google form if they're asking you to factor it. Let's try number 8. Make your sign. What goes into both? You can say 4, but let's say we can't think of 4. We're going to take out a 2. 8n divided by 2 is 4n, and 12 divided by 2 is 6. We bring down that plus sign, and you can see that we can still take out another 2. 4n divided by 2 is 2n, and 6 divided by 2 is 3. Now you can see that we can't take anything else out of 2n and 3, so we put our parentheses around it, and then we gather up these, multiply them together, and that is our GCF of 4. To make sure you're right, just distribute, and you can see it's your original problem. All right, number 9. Right off the bat, did you notice that both terms have negative signs? So let's take care of those. We have negatives for both, so I'm going to factor out the negative. And I'm going to factor out a 3, because 3 goes in both 9 and 15. So negative 9c divided by negative 3 is positive 3c. Plus negative 15 divided by negative 3 is a positive 5. And now we don't need these parentheses down here, So we're going to rewrite this as 3c plus 5, and there's nothing else we can take out, so we'll add our parentheses and put our GCF right in front. And if you want to make sure you're getting it right, all you have to do is go negative 3 times 3c is indeed negative 9c, and negative 3 times 5 is indeed negative 15. So you know you are set. 3 more of practicing together before you're off on your own. All right, now, it's always been recommended since the beginning of the school year to use the additive inverse on all subtraction signs. And basically it's just turning your subtraction sign into an addition and then doing the opposite of what follows. And so we have here negative 10x minus 15, so additive inverse. And you can see they both have negatives. If you hadn't have done the additive inverse, you might not have seen that. So we can factor out a negative. And we can know that 5 goes into both. So negative 10x divided by negative 5 is positive 2x, and negative 15 divided by negative 5 is positive 3. Bring down the plus sign. There's nothing else that goes into these, no other factors. So we take our GCF and move it in front. And remember, you can always check by the distributive property. Number 11. Let's use additive inverse. Now, do they both share a negative? They don't. So there's no use taking a negative out. So let's go ahead and start. What can we take out of 18y plus negative 24? Well, it looks like we can take out a 6. But let's say I don't automatically think of 6. Let's say I think of a smaller number, such as 2. And now this is going to take a much longer road, but we'll get to the same answer. 18y divided by 2 is 9y, and negative 24 divided by 2 is negative 12. Well, I can take out 3 from both still, so I'll take out 3, and 9y divided by 3 is 3y, and negative 12 divided by 3 is negative 4. Now I can't take out anything else, but if you put the parentheses around this right now and multiply these, this is 2 times 3, which is 6. Now if you look, it's correct, but there's a better way to write this, as we learned earlier in this unit. And that is 6 times 3y minus 4 is the better way to write the answer. And our last one, number 12, a square mirror. What kind of mirror is it? Square. Has a perimeter of 10x plus 20. That's the whole entire perimeter, inches. What is the length of the mirror? Well, if it's a square mirror, it has length and it has what? Width. Either way you look at it, it's length and width. Now they're the same, but it does say that the perimeter together all the way around is combined to be 10x plus 20. So to do this, we need to write 10x plus 20, and we know how many sides are there to a mirror. There's 4 because it's square. So if we put a 4 here, and we go ahead and take this apart, 10x divided by 4 is, that's tough, isn't it? So what is 10x divided by 4? It's 10x fourths, correct? And what is 20 divided by 4? 20 fourths. Okay? Is there anything else we can take out? No. So I drew this next division bar. I didn't need to do that. So let's go ahead and simplify these two fractions. 10x over 4 is 5 over 2 x's plus 5. Is there any common factors left? No. So we put our parentheses around it, and what do we move down in front? 4. That means there are 4 sides to our mirror. Well, what's one side? One side is 5 halves x plus 5. That's one side of the mirror. How do we know that's true? Well, we can use the distributive property to find out that this is actually equal to our original, and that was the perimeter. All right, now it's time for your turn. So I'm going to have you, there's quite a few of them, there's 12 of these. I'm going to have you go ahead and start and do 13, 14, and 15 all together. Pause the video now and come back to see if you got them right. All right, here we have the answers. And I do want to talk about number 13. It had a minus sign, but I knew that it would only produce one negative sign if I used the additive inverse. So I just left it as subtraction because I knew I would have to make it go back to subtraction. Okay, so that one is factored out. They're all factored out using the upside down cake method. Let's take a look at number 16 through 18. Now, 16 through 18, there is one of them that you'll be factoring out a negative, and hopefully you find which one it is. Pause now. All right, we're back here, and we're looking at 16, 17, and 18. And before I said pause the video, I said there's one of them that has 2 negatives. And as I got started, the class helped me to see there's actually 2 of them, 16 and 18. So you're taking out negatives on 16 and 18. I apologize for not seeing that. But there's the answers, and that's how it works. And so once you get your things corrected and you make sure you know how to do these, you're going to go down and you're going to complete the rest of the sheet, 19 through 24. Pause now. All right, wrapping it up, looking at 19 through 24, I do want to mention number 20. It is tricky. And so when you do all of your work here, you're going to get 4c, basically 4c times this stuff. But inside there, we can write this more appropriately, use the commutative property, and turn this around to be 8n plus negative 3. And remember, adding a negative 3 is the same thing as subtracting a positive 3. So this right here, we had to do a little bit of trickiness to make sure it looks appropriate. Okay? And then we had to do the same thing in number 22. We had to do some little twisting around here using the commutative property with 2 plus 5t to make 5t plus 2. And then again, it happened in 23, and that was like all about the bananas. And then the last one, I'm sure you got the last one. You're like, what can I take out? Well, there is nothing to take out. And so we're just going to write this: cannot be factored. Okay? Now, in the Google Forms, it's going to tell you what to do when you run up against something like this. It'll probably say something, you have to write something in, cannot be factored with no spaces. So as long as you can type it correctly with no spaces, you'll be just fine. All right, we're going to run right down here into a couple of problems. I just want to go over the how to do these with your directions. So you definitely want to put your first name, last name, date, and period. And then you read directions carefully. Find the GCF. It's funny, in the notes we learned that it's the LFI, the largest familiar ingredient. So of the pair of monomials. Okay, so this one, it's the upside down cake. That's all it is. And you just work it out. This one's kind of in the way here. So 7 goes into both, goes in 4 times, and it goes in there 6 times. And when you do that, you're like, oh, I can take out something else, like a 2. And that's 2 times, and that's 3x times. And so these are the leftovers, but these two multiplied together gives us the GCF, what it's looking for. So to answer this one on the Google form, you just put in 14. And that's how all of those work. You have to do all the odds and all the evens. Pretty self-explanatory. And then down here, the next set of directions says factor each expression, and we just got doing that in the notes. It says if the expression cannot be factored, write cannot be factored. Use algebra tiles if needed. So when we come down here, we set this up upside down. The 10's in the way, so I'll kind of cross it out. And 3 goes into both. 3 goes in 12x 4x times, and 3 goes into 3 once. We'll bring down that plus sign. We make it into our parentheses, and we put our GCF out in front. And in Google Forms, you just simply write 3 parentheses 4x plus 1 end parentheses. And remember how we did the last 6 of them on the notes? Make sure they're going in the right order to get the credit. And that's it. These are far easier than the ones on the notes.